Hello and welcome to this extension, or really just a follow-up video on conductors in electrostatic equilibrium. So in an earlier video we introduced the idea of electrostatic equilibrium and looked at what the field around a conductor had to do or look like in order for us to actually assert that that conductor was indeed in electrostatic equilibrium. And then I went into saying things like if you had some conductor, whatever shape, there's some crazy shape, then we knew that a couple of things had to be true. The electric field had to be perpendicular at every point to the surface, because if it wasn't, then you could decompose that. So I'll draw it in a different color in fact. If I draw this crazy vector here, well, I can decompose that vector in terms of what it's doing along my surface, which I'm just making thicker so you can see what I'm doing. I can decompose that into a component that is along the surface and that is perpendicular to the surface. But the component along the surface would mean that there is a field along the surface, there is a force along the surface, I have charges on the surface of my conductor, and so those things would move. So we had said that it had to be perpendicular to the surface and in fact zero inside. Now there's a nice additional consequence of all of this, which is if there is no electric field either along the surface or inside it, then I can ask the question, what's going on with the potential everywhere inside this conductor? So remember that the potential is supposed to be related to the change in potential energy as you move a charge around. And the potential energy was equal to the negative of the work done by the electric field. So if I pop down a charge here and I move it here, then I would have gone and said what was the effect, this is my displacement. I take Q times E times displacement to calculate that change in potential energy, or basically the work that I'm doing. So what is Q times E times D? This is D, but E is 0. I didn't do any work, or the electric field didn't do any work as I moved that charge along. So if there's no work done, there's no change in potential energy, there's no change in potential. So a very nice additional comment to make, besides the fact that E is 0 and everything is perpendicular, is the fact that V, or at least delta V, is 0 as you move along any point of this conductor. So a conductor in electrostatic equilibrium is an equipotential object, really. You could call it a surface, but it's really the whole three-dimensional thing of that conductor is all at the same potential.